Okay, we're just going to look at a few other symmetry properties with cosine and sine, and then we're going to look at the Pythagorean identity in this video. So the first thing we're going to look at are complementary relationships, and complementary implies angles that add up to 90 degrees. So if we look at this first statement here, it says that the sine of pi over 2 minus theta, or 90 degrees minus theta, is equal to the cos of theta. So basically what that's saying is that if, say, theta was 30 degrees, and I'm just going to work in degrees here just for the sake of ease, that would mean that the sine of 90 minus 30 degrees is equal to the cos of 30 degrees, or that the sine of 60 is equal to the cos of 30. Okay, so basically you probably know that from your exact values, that the sine of 60 is actually equal to the cos of 30 degrees, and that's going to hold for any two angles that add up to 90 degrees. Similarly, if we've got the cos of pi over 2 minus theta, that's going to be equal to sine theta. Okay, over here, if we're looking at theta plus 90 degrees, or theta plus pi over 2, the sine of pi over 2 plus theta is equal to cos theta. But if we have the cos of pi over 2 plus theta, that's equal to the negative sine theta, and that's because sine is negative in that quadrant there. Okay, so we'll take a look at how we might use this. So if we know that sine of x is equal to 0.4, what would the value of cos of pi over 2 minus x be? Well, we know that cos of pi over 2 minus x is just equal to whatever the sine of x is, and we know the sine of x is equal to 0.4, so that's just equal to 0.4. Now for b, if I have something like this, sine of negative x, that's the same as saying the negative of sine x. Again, sine x, we're told, is 0.4, so that's equal to negative 0.4. And in c, this should say c here, I've got cos of pi over 2 plus theta. Well, I know that that's going to be equal to the negative of sine of theta. Sorry, I should have put an x there, not theta. Okay, so sorry, I'll say that one again. Cos of pi over 2 plus x is equal to the negative of sine x, which is just going to be negative 0.4 with that value we were given originally. Okay, last thing we're going to learn in this unit is called the Pythagorean identity. Now, we know that from the unit circle that we can make a right angle triangle where the length of that's x, which is equal to cos theta, and the vertical distance is y, or sine theta, and the radius or the hypotenuse of this right angle triangle is equal to 1. Okay, so using Pythagoras' theorem, we know that sine of theta squared plus the cos of theta squared is going to be equal to 1 squared. Okay, we more commonly write this identity as cos squared theta plus sine squared theta is equal to 1. Okay, so this is an identity that you need to remember. Just know that this is the same as this, okay? We just normally write it this way, as sine squared theta instead of sine theta squared. Okay, so the question says, if sine of theta was equal to 2/5 and theta is between pi over 2 and pi, what are the exact values of cos theta and tan theta? Well, let's just think about a little bit what this question is saying. So first of all, we know that theta is between pi over 2 and pi, which means that it's in the second quadrant. So that means cos and tan are both negative in this quadrant. So I know my answers must be negative. Okay, now using my identity here, I know that cos squared theta plus sine squared theta is equal to 1. Now I know that sine of theta is equal to 2/5, so I can substitute that into the equation. So I've got cos squared theta plus sine theta is 2/5, so 2/5 squared is equal to 1. And now I can rearrange and solve for cos. So cos squared theta plus 4/25 is equal to 1. I'm going to subtract 4/25 from both sides to get cos squared theta is equal to 21/25. And I'm just running a little bit out of room here, so I'm going to continue up here. Now, if I have cos squared theta and I want to get that on its own, I just need to take the square root of both sides. To get cos theta is equal to the square root of 21 over 25, or simplifying that, the square root of 21 over 5. Okay, and I know that because it's in that second quadrant that this is going to have to be a negative value because I'm looking for values between pi over 2 and pi. All right, now let's take a look at tan theta. I know the identity tan theta is equal to sine theta over cos theta. So filling in my values for sine and cos. Sine theta was 2/5. Cos of theta was negative root 21 over 5. That looks really awful, but I'm dividing fractions, so I'm just going to flip and multiply. I get 2/5 times negative 5 over root 21. Those 5's cancel, which gives me a final answer of negative 2 over root 21. Okay, so there's my exact value for tan of theta. I'll just write that a bit more clearly up here. Okay, so you can try questions from 16K now. You can do 1, just do every other one, 2, and then questions 4 and 5 from this exercise.